Good evening, everyone. Welcome to the session number 46 from the playlist of IIT-JEE Main Physics. The topic is the magnetic moment and the chapter is the moving charges and magnetism or the magnetic effect of current. So, based on this topic, I have selected one question for this session, which is taken from one of my books. And the question is: a square loop of length L carry a current I. It is placed in the XY plane as shown in the figure number 1, and then it is bent, then half of it is bent as shown in the figure number 2. So this is the figure number 2, in which half of this square loop is bent in such a way that half of it is lying in the XY plane and the other half is lying in the YZ plane. And in the figure number 1, the entire loop is lying in the XY plane. So the magnetic moment there are 4 options here. It will increase after the bending of the square loop, or it will decrease after the bending of the square loop. It will remain the same, or it will depend on the direction of the current. So here we will first of all calculate the magnetic moment of this square loop which is lying in the XY plane. Now the magnetic moment is equal to M is equal to N I into A. N is what? It is the number of turns in the loop. I is the current which is flowing in the loop, and A is the area of cross section. So here the current is I. Let us consider that the number of loop is equal to 1. So in the first case, that is when the loop is lying in the XY plane, let us say the magnetic moment is equal to M1. That this will be equal to I, and area of cross section will be equal to L into L, that is equal to L square. Now let us come to the second case. Now the direction of the magnetic moment is given by the right hand thumb rule, and since it is lying in the XY plane, therefore the direction of the magnetic moment due to this current carrying square loop will be along the Z direction. Now let us come to the figure number 2. So here this square loop is bent in such a way that half of the loop is lying in the XY plane and the other half is lying in the YZ plane. So let us first of all find the magnetic moment due to this loop which is lying in the XY plane. So I am just denoting here the magnetic moment as MXY. So here the N is equal to 1, that is number of turns is equal to 1. The current is the same I, and here the area of cross section of this loop which is lying in the XY plane will be equal to L into L by 2. So this is equal to I L square by 2. Similarly, the magnetic moment due to the loop which is lying in the YZ plane, this will also be the same, that is I, the magnitude will be the same. Now the magnetic moment due to the loop which is lying in the XY plane, it will be along the Z direction, and the magnetic moment of the loop which is lying in the YZ plane, YZ, this will be along the X direction. So the resultant magnetic moment in the second case, let us say it is M2, this will be the under root of mx y whole square plus m yz whole square. Here mxy is the magnetic moment due to the loop which is lying in the xy plane, and myz is the magnetic moment due to the loop which is lying in the yz plane. So its value will be equal to this will be equal to M2 will be equal to, here mxy and myz, the magnitude of both the magnetic moments are equal. So the value of M2 will be equal to root 2, and this will be getting root 2 by 2 I L square. If I substitute the value of mxy and myz in this equation, I will be getting this value, and this value is equal to, root 2 is equal to 1.414, so divide by 2 I L square. So M2 will be equal to, if I divide 1.414 by 2, this will go to 0.707. 0.707 IL square. Now IL square is basically equal to M1. So we can see here that the magnetic moment has decreased when this square loop was bent in such a way that half of it is lying in the xy plane and the other half is lying in the yz plane. So the correct option here is B. And here the direction of the current will not affect the magnitude of the magnetic moment, irrespective of whether the current is flowing in the clockwise direction or the anti-clockwise direction. The magnetic moment will decrease if this square loop is bent in such a way that the half of this square loop is lying in the xy plane and the other half is lying in the yz plane. So thank you very much for joining this session. In the next session, I will be coming up with a question which will be based on the magnetic induction, or the variation of the magnetic induction due to a rotating disk. So till then, have a nice day. Bye.